We already know how to solve proportions, so now we're going to use that information to be able to solve application problems. The type of problems I'm talking about will be problems such as if you are doing a recipe for a big outing and your recipe works for 12 people, but you need to make it for 100 people. You need to know how much material you need to double, triple, or whatever the amount you need in a recipe. If you're going to a store to buy wallpaper and they tell you how many square feet that roll of wallpaper will cover, you need to determine how many rolls that you're going to buy. Or painting walls, or putting floor tile down. So there's a lot of different application problems that come up that we can solve using proportions. Okay, to set up a proportion to solve an application problem, what's going to be important is we need to know that the units in the numerator of our ratios must be the same, and the units in the denominator of our ratios must also be the same. It's very important that the numerator of the first ratio has the same unit measure as the numerator in the second ratio, and the same is true for the denominator. A package of puff wheat that contains 600 calories. How many calories are in a 5/10 of an ounce of the cereal? Now this is something we come across all the time. Everybody is calorie counting nowadays, so we want to make sure that we're not overdoing or underdoing. So what we want to do is we're going to set up two ratios using this information. Okay. Our first bit of information is that there are 6 ounces that contains 600 calories. So we have 6 ounces to 600 calories. So that's going to be our first ratio. Our first ratio is going to be 6 ounces to 600 calories. Now, when we set up the second ratio, we're going to need to match these. So that means we're going to put the ounces on top and the calories on the bottom. We want the ounces on top and the calories on the bottom. Now, with the question that's asked, how many calories are in 0.5 ounces of the cereal? The calories is what we're looking for, so the calories are going to be X, and the ounces is 0.5. Now we've set up a proportion. Remember, we had 6 ounces to 600 calories. That was our given value. That's the original relationship. Now we want to know the amount of calories in 0.5 or 0.5 or 5/10 of an ounce. Now that we have our proportion set up, we want to solve the proportion. Remember, how we solve a proportion is we cross multiply. We multiply the extremes and set that equal to the product of the means. So we have 6 times X is going to be 600 times 5/10. It gives me 6X is equal to 600 times 0.5 is 300. To find X, we need to divide both sides by the number that's with it. So we're going to divide both sides by 6. Now, when we do that, of course, these cancel. X is equal to 300 divided by 6, which is 50. Therefore, there are 50 calories ES in 0.5 ounces. That's what we're looking for. And there's 50 calories in 0.5 ounces. Now let's look again. Our first relationship, we were told that in 6 ounces there were 600 calories. In 6 ounces, there were 600 calories, so that's our first ratio. 6 ounces to 600 calories. We were looking for how many calories were in 0.5 ounces, and what we need to remember is, since we put ounces in the numerator in the first ratio, we must put ounces in the numerator for the second ratio. Calories was in the denominator in the first ratio, so calories must be in the denominator for the second ratio. Once we have our proportion set up, then we cross multiply. We go back to remembering how to solve a proportion. And once we do the arithmetic from there, we multiply and then divide both sides by the number with the unknown, and we get our answer. So in this one, there are 50 calories and 0.5 of an ounce. Our second example. Ron uses 2 pounds of fertilizer for every 100 square feet of lawn. At this rate, how many pounds of fertilizer will he need to fertilize 2,500 square feet of lawn? In other words, he knows on the bag that he's going to buy, it says that for every 2 pounds, it fertilizes 100 square feet. But his lawn has 2,500 square feet, so he needs to know, how many pounds do I have to buy? That's what this is asking. So Ron uses 2 pounds of fertilizer for every 100 square feet of lawn. That gives me my first ratio, 2 pounds to 100 square feet. 2 pounds to 100 square feet. So that's going to be my first ratio, 2 pounds to 100 square feet. Now my second ratio has to match that. Since I have pounds in the numerator on my first fraction, I must put pounds in the numerator on my second fraction. And since I have square feet in the denominator of my first ratio, I must have square feet in the denominator of my second ratio. Now, which of these is the unknown? What am I looking for? Okay, according to this, at this rate, how many pounds of fertilizer will we need? So how many pounds of fertilizer is our unknown? So we use X with the pounds. And then there's 2,500 square feet of lawn, so that's going to have to go here in the denominator of the second ratio. Again, our given ratio, we were told 2 pounds worked for 100 square feet. That becomes our first ratio. That's the relationship, 2 pounds to 100 square feet. That's our first ratio. Second ratio has to be set up exactly the same way, because if they're equivalent, they have to match. If they're equivalent, they have to match. We're looking for how many pounds to cover 2,500 square feet. So pounds to square feet. And now that we have our proportion set up, what we want to do is solve the proportion. And we solve the proportion by cross multiplying. So we're going to multiply 2 times 2,500, and that's equal to 100 times x, the product of the means. Now 2 times 2,500 is 5,000, and that is just 100x. Now to solve this, we need to divide both sides by the number with x, so we're going to divide both sides by 100, and x turns out to be, the 100s cancel, 5,000 divided by 100 gives us what? 50? Same answer as the first example. Okay. Now 50 represents pounds, so that means that 50 pounds will be needed for 2,500 square feet. 50 pounds is what we were looking for.